How far back does direct sunlight shine into the chamber of Newgrange, and where does it strike? In the days surrounding winter solstice of 2020, a study was carried out by the OPW and National Monuments Service, and some of the findings were published in Archaeology Ireland the following year. During the study, the entrance gate was covered so that light could only enter Newgrange through the roof box, and cameras were set up in the chamber to capture observations for 41 days around winter solstice. The study produced excellent data relating to the timing and positioning of light within the chamber over multiple days. Some of the best footage ever captured of winter solstice sunlight in the chamber of Newgrange came out of this study, and some of the days surrounding the solstice were broadcast as live streams. Within a few days of the actual solstice, there is no appreciable difference in the position of sunlight. The light recorded on the 24th of December was of particular value, likely because there was minimal cloud interference that day, and this date was the focus of the article in Archaeology Ireland. The footage captured shows how ambient light and direct sunlight interact within the monument. This ambient beam of light appears when the sky brightens and is caused by light bouncing off the sky and shining into the chamber after being restricted through the roof box and the passage. If your eye was positioned anywhere in the ambient beam, you would see a bright patch of sky through the roof box. The direct beam of light appears when the sun comes into line with the roof box. If your eye were in the direct beam, you would see some part of the actual disk of the sun. This animation will show the modern position of the sun as it rises and enters the roof box. It has been synchronized with the time-lapse footage from the study to show how the pattern of ambient and direct sunlight unfolds on the floor of the chamber in relation to the position of the sun in the sky. Note that the roof box overlay represents a view far back on the floor of the chamber, and so the disk of the sun only shows when the direct beam is long but narrow, while the sun is low in the sky, but off-center. The sun appears to leave the roof box as viewed from the rear of the chamber floor as it becomes more centered, but if it were viewed from further along the floor, the bottom of the sun would still be visible in the center of the roof box at this point, creating the maximum width beam of direct sunlight, but not reaching as far back. The interaction of direct sunlight on the floor of the chamber during the winter solstice is an amazing sight to behold even today, but the situation was a little different 5,000 years ago during the Neolithic period when Newgrange was built. Because the tilt of the Earth today is less than in the Neolithic, modern winter solstice occurs when the sun is at declination negative 23.44 degrees, instead of negative 24 degrees. This means that in the past, the axis of the Earth was more tilted, so the sun rose a little further south at the winter solstice than it does today. At that time, the sun was more centered in the roof box, and so the direct beam reached further back into the chamber. Today, the sun rises towards the left of the roof box as seen from the chamber, and as it rises, it comes more in line with the roof box and passage. But it is higher in the sky by then, and so its light can't reach as far back in the chamber as it once did. The ambient beam represents the maximum range of direct sunlight. You can see in this image that the beam is obstructed, but there is a faint indication that the light reaches even further into the chamber. The light is blocked by fragments of the broken stone basin in the rear recess. Depending on the estimated width and profile of the basin when it was intact, as well as the possibility of different positioning, it is likely that direct sunlight would reach all the way to the back of the recess. The width of the roof box and the stones of the passage determine the maximum width of the beam. Any leaning orthostats at the height of the roof box may restrict the beam width slightly more than originally intended. When the sun is centered with the roof box, the direct beam of sunlight is at maximum width. How far back the direct beam reaches is determined by the height of the roof box in relation to the floor of the chamber. The passage of Newgrange slopes upward to the chamber, so that the floor of the chamber is level with the roof box sitting above the passage entrance. When the sun is at the height or altitude of the roof box, direct sunlight can reach the maximum distance into the chamber. When Newgrange was built and the sun rose a bit further to the south, it would be centered in the roof box at the correct altitude to shine all the way back into the rear recess of the chamber, matching the full width and length of the ambient beam with direct sunlight. It would have been absolutely magnificent to see. For many days either before or after the solstice, even when rising further north, the sun still comes into alignment as it comes up, but the further from the solstice, the higher it has to be in the sky before it will be centered. This means the direct beam of light won't be as far back in the chamber. Today, direct sunlight shines into the chamber for 18 days before and after the winter solstice. But when Newgrange was built, the situation was a little different. To find out more about exactly how many days direct sunlight used to enter the chamber, and how this might be related to calendar intervals used by megalithic builders, please see part 1 of this video. Depending on the exact slope of the chamber floor, the direct light beam would have likely reached to the very back wall of the rear recess, or possibly even up the wall some distance. It is also interesting to note that the builders of Newgrange did not intend to have the beam of light centered in the rear recess, but instead directed it toward the back corner. This is a pattern that seems to be repeated at other passage tombs, such as Maes Howe in Orkney and Bryn Celli Ddu in Wales, where the solstice alignments aren't directly centered. This could even be of importance in the study of shorter passages, as light reaching along from a maximum angle to a corner can still be very exact. Usually for such passages, the central orientation axis is the focus when alignments are considered, and so there is much work to be done in this area. Because of the lessening of the tilt of Earth's axis, sunlight no longer reaches the maximum possible range at Newgrange. However, the moon can still reach these positions at certain times over the course of an 18.6-year lunar cycle, and it is hoped that at the next opportunity, moonlight might be recorded as the proxy for the ancient range of direct sunlight in a similar way to how the Solstice Project was set up. Thank you for watching, and please see the video description for links to sources and other related videos, as well as links to contribute to the research and educational work of the Archaeoastronomy Database. Your support is greatly appreciated.